order homogeneous PDE, higher order homogeneous PDE. And today we'll continue with the same topic here. We'll have different types here. Yesterday we have discussed two types here. The type 1, type 2. Type 1 is particular integral is exponential function right hand side. Type 2 is cosine or algebra sine function in the right hand side. Right hand side. We'll continue with some more problems in the type 2. Some more problems in the type 2. D square, take one more problem here. Solve d square minus 3dd dash plus 2d dash square. 2d dash square of z equal to sin x cos y. Equal to sin x cos y. Yes, and the solution given PDE is d square minus 3dd dash plus 2d dash square of z. You write in terms of single cosine or cosine function 1 by 2 of sin a plus b plus sin a minus b. Sin a minus b. Sin a plus b, sin a minus b form we can write here. Sin a cos b form here. Therefore, we can write as 1 by 2 of sin a plus b, sin a minus b. CF we can write the auxiliary equation is you replace d by m, d dash by 1, d dash by 1, d by m and d dash by 1, d dash by 1. Can write m minus 1, m minus 2 is equal to 0, m equal to 1 comma 2. Implies CF is equal to pi 1 of y plus x, pi 2 of y plus 2x, y plus m1x plus y plus m2x. This is CF, complementary function. And this is complementary function that you can write. Correspondingly, you have to write particular integral also. Now, we think about particular integral. One by d square minus 3dd dash plus 2d dash square. 3d dash plus 2d dash square. 1 by 2 of sin x plus y plus sin x minus y. Sin x minus y. We take 1 by 2, split two particular integrals. 1 by d square 3d dash plus 2d dash square of sin x plus y plus 1 by d square minus 3d dash plus 2d dash square of sin x minus y. Sin x minus y. What are the things you have to follow here? Replace d square by minus a square. This is a is minus 1, b is a is 1, b is also 1 here. Minus a square. D dash by minus ab. Minus into 1 into 1 ab. 1 into 1 only. 1 into 1. D dash square by again minus b square. Minus. Here is also the same thing here. Same thing you have to follow, d dash, and here is also replace replace d square by minus 1 square, d dash by minus 1 into 1, d dash square by minus 1 into minus 1. Here minus 1. AB is present. B is here minus 1. B is minus 1. Ax plus by form. B is minus 1. 1 into minus 1. And here minus 1 square. Minus 1 square. In that manner. Therefore, what are the things you can get here? 1 by 2. D square is minus 1. Minus 1. Minus 3 into minus 1 again. Plus 2 into minus 1. 2 into minus 1 sine of x plus y, and here is also d square minus 1 minus 3 into, already here minus 1 minus minus plus 1 plus 1 plus 2 into minus 1 2 into minus 1 into sine of x minus y, x minus y. Here you are getting that plus 3 plus 3 minus and then minus 2 plus 3, this is plus 3 minus 1 minus 2 minus 3, it becomes 0, 0, denominator becomes 0, denominator becomes 0, 0, and here minus 1 minus 3 minus minus 1 minus 3 minus 2 minus 5 minus 6 not equal to 0. Because of denominator 0, denominator 0, what is the idea? Can anyone have idea? What are the procedure you have to do?
Multiply x in numerator and differentiate the denominator with respect to d.
The past, yes, very good, very good. Here you have to multiply numerator with respect to by x and denominator with respect to d partially, partially here, and here therefore you can get it as what will be the thing you have to proceed means multiply numerator with x and differentiate denominator partially with respect to d, partially. These are all shortcut method d, and here no problem, as usual only here 1 by 2 of here obvious thing here minus 5 minus 6 minus 6. So 1 by 2 of here put one x, here x, and the differential denominator 2d minus 3 dash 3d dash. D is 1 and here totally 0, partially with respect to d dash means 0, and here you can get minus 3d dash, here 2 2d 2d minus 3d dash here, partially with respect to d, and you can get 3d dash and 0 d dash 0 here, the sine of x plus y, and here minus 1 by 6 sine of x minus y, minus 1 by 6 sine of x minus y. Now you see that here again, again we are getting denominator as a d and a d dash form. It is like a ld plus md dash form here. For in order to get, but you know the procedure, only procedure that replace d square, sine or cosine, you know this procedure only, replace d square by a square and so on here. Therefore again, but it is not d square, there is no d dash so on. Therefore in order to get again d square, d dash square, that type of form, multiply by
Conjugate.
conjugate, multiply by conjugate. Here x into 2d plus 3d dash whole divided by 2d minus 3d dash, 2d minus 3d dash, 2d plus 3d dash, multiply by conjugate, and keep this one as it is here, and here minus 1 by 6 of sine of x minus y as it is. You have to take this x outside of the operation, further operations here, then you can get 2d plus 3d dash divided by a square minus b square, a plus b, a minus b, or a square minus b square, minus b square. You have to remove this x from the further operation. You have to keep this one only further operation here. 1 by 6 of sine of x minus y, sine of y. Now you see that d square, d dash square form, replace d square by minus a square minus b square, that type of thing you can follow here. And get it as replace d square by minus 1 square d dash square by again minus 1 square here. Again same thing. 1 by 2 of, you take x outside here. Numerator is 2d plus 3d dash. Minus 1 square minus 1 square. Minus 1 square minus 1 square. Or minus 4 minus minus plus 9. Minus 4 plus 9. Minus 4 plus 9. Minus plus sin of x plus y. Minus 1 by 6 of sin of x minus y. It is 5 of 5. 1 by 2 of x by 5. X by 5. Now d stands for dou by dou x. D dash stands for dou by dou y. Dou by dou y. So we have to operate further here. D of sin x plus y plus 3d dash of sin x plus y. Sin x plus y. Further minus 1 by 6 of sin x minus y. Therefore 1 by 2 x by 5. D stands for dou by dou x. Dou by dou x means partially with respect to x. And you can get 2 cosine of x plus y. X coefficient is 1 only. Similarly, d dash stands for partially with respect to y. It is also cos x plus y. Cos x plus y. This is the term. Minus 1 by 6 sin x minus y. Since d means dou by dou x and d dash means dou by dou y. D dash means dou by. Now both are cos x plus y, cos x plus y. Therefore 2 plus 3, 5. 5, 5 get cancelled here. So we can get x cos of x plus y here. X cos of x plus y. X cos of x plus y and minus 1 by 6 sin of x minus y. Minus 1 by 6 sin of x minus y. This 5, 5 get cancelled. Or can write, if you write 12 here, 1 by 12, you can get as 6x cos of x plus y minus sin x minus y. This is your particular integral. Therefore, general solution is z equal to cf plus pa. You write cf and pi once again. Write cf and pi once again. All of you understand, I think, easily. Here, after the first step, you are getting 0. Therefore, you are going to put x in the numerator and differentiate denominator partially with respect to d here. After that, you are getting ld plus md dash form here. Therefore, you have to multiply by conjugate here. Again, now you are getting denominators here. D square and d dash square form here. Then you can easily replace it. Easily replace further. So this will be the idea we can follow. Okay, right. The same way, I'll try and give the answer for this one here. Solve d square minus 2dd dash plus d dash square of z. D dash square of z equal to cos of, or otherwise you can write yes, anyway, cos of x minus 3y. A simple problem only. Cos of x minus 3y. D square minus 2dd dash plus d dash square equal to cos of x minus 3y. Yes, all of you try in the same manner and give your answer here. What are the roots and what will be your particular integral? Please tell that. What will be complementary function, particular integral? After completion, give your answer.
Sir,
Uh,
sir, one doubt, sir. If the roots are equal, we need to I1.
if the roots are equal, you would write pi 1 of y plus m1x plus x into pi 2 of y plus m1x.
Okay.
Here m
Sir,
equal to 1
CF,
1 na?
yes, sir.
Mm.
CF is phi 1 of y plus x
Pi 1 of y plus x.
plus x into phi 2 of y plus x.
Yes, very good.
Particular integral is minus 1 by 16
Mm.
cos of x
Uh,
minus 3y.
yes, very good, very good. Yes, your particular integral is equal to minus 1 by 16 of cos of x minus 3y. Cos of x minus 3y. Yes, this will be your idea. I think everyone getting the same answer. Your roots are equal, therefore you can write as pi 1 of y plus x into pi 2 of y plus x. Particular integral equal to minus 1 by 16 of cos of x minus 3y. Cos of x minus 3y. That manner I can write. Okay. This is type 2. Then we move on to type 3 here. Type 3 is RHS is equal to an algebraic polynomial. Algebraic polynomial in both x and y. An algebraic polynomial in both x and y, like x power m, y power n form. X power n, y power n form. Not only this one, any addition of x relation is also possible. X square, y square plus xy and that manner. Addition of relation. An algebraic polynomial in both x and y, x power m, y power n. In this case, your particular integral equal to 1 by function of t comma d dash x power m, y power n. X power m, y power n. Then here you have to take because all the equations, you see that all the equations, the C equations we consider as whatever the thing ends started here, d square then d dash square, otherwise definitely it ends with the d dash square, that type of thing here. Okay? Definitely every time you can find a derivative. Okay? Every time you can find a derivative here. Okay? You can find a derivative. Therefore, in that case, you have to take the whole function. You have to take highest power of d as a common element here. In phi of d comma d dash, phi of d comma d dash, take highest power of d as a common element. Highest power of d as a common element. The element, common element. Then it becomes a function of d, a function of d into 1 plus psi of d comma d dash, psi of d comma d dash into x power m, y power n. 1 by g of d, you take it into the numerator, psi of d comma d dash whole power minus 1, x power m, y power n. X power m, y power n, type of thing we can get that. Then we can apply binomial series. Binomial series for this expression. Apply binomial expansion. Binomial expansions and proceed further. And proceed further. And proceed further. It is like a 1 plus x whole power minus 1. 1 plus x whole power minus 1. You have to expand the series. Expand the series. But in the expansion, we can stop the series. Depends upon what will be the highest power of highest power. Either m gets the highest value or n gets the highest value. Okay? Suppose we have y cube means you have to proceed up to d dash cube. Okay? D dash cube here. In that manner here. Okay? Therefore, you can stop the series depends upon the power of x and y. Okay? Power of x and y. Okay? Power of x and y. That will be the idea we can. We can stop the binomial series binomial series uh, up to the power of x and y. That one we can proceed. This will be the idea of what when you have algebraic polynomial. Algebraic polynomial in the right hand side. Algebraic polynomial in the right hand side. You have to take highest power of d as a common. Suppose d square is present, you have to take d square as a common. D cube is present, you have to take d cube as a common element. In that manner, you have to proceed. Solve d cube minus 2d dash square d dash. 2d dash square d dash. D cube minus 2d square d dash z is equal to of z equal to 3x square y. 3x square y. Also power 3 power 3. Yeah. It is right hand side. RHS is a polynomial. The solution complementary function auxiliary equation is m cube minus 2m square equal to 0, m minus 2 equal to 0, m square 0 comma 0 2. Pi 1 of y plus x pi 2 of y, 0 0, pi 3 of y plus 2x. Pi 3 of y plus 2. Y plus mx, m is 0, therefore y only. It is also 0 for x. You can use x. Then you can get particular integral. One by d cube minus 2d square d dash of 3x square y. 3x square. You have to take highest power of d as a common element. D cube is here. You have to take d cube as a common element. Then you can get it as 1 by d cube. On d square get cancelled here. Therefore, it will be 1 by 2d dash by d of 3x square y. To take this one in the numerator, 1 minus 2d dash by d. 2d dash by d power minus 1. Power minus 1. 3x square y. 3x square y. Take it into the numerator, power minus 1. So it is like a 1 minus x whole power minus 1. 1 minus x whole power minus 1. Therefore, you can write it that 1 plus x, 1 minus x whole power minus 1 will be everything is plus 1 plus x square and etc. here. Therefore, we can write it as 1 by d cube of 1 plus x d dash by d 2 d dash by d plus x square plus x cube of 3x square y 3x square y. Now you operate denominator d later, but numerator is you are going to operate first here. Your numerator denominator 1 by d means integration. D dash means differentiation. D and D dash means differentiation. Here 1 by reciprocal means integration. So now we are going to operate numerator first here. Numerator elements first here. The numerator it contains only d dash. D dash means dou by dou y. D dash square and so on here. Dou by y here. It is dou square by dou y square. This dou cube by dou y cube and so on. But when you concentrate on y, it is we have y power 1 only. Y power 1. So y power 1 means it is enough to consider d dash only. D dash square definitely 0. When you operate with a higher derivative, it will become 0 here. It will become 0. Therefore, it is enough to consider only one expression 1 by 2 by d of d dash here. 3x square y. Neglect d dash square and higher powers. D dash square and higher powers. That is not necessary because it becomes 0 here. Then 1 by d cube of d dash of 3x square y, and here is also 3x square y. 3x square y. You operate here. 3x square y and 3x square y. Then 1 by d cube of 3x square y, 2 by df, one derivative of this one, dou by dou y. It will be dou by dou y. D dash means dou by dou y of 3x square y. D dash means dou by dou y of 3x square y. 1 by d cube of plus 2 by d of dou by dou y means you can get 3x square only. 3x square only. 3x square. Now 1 by d stands for integration partially with respect to x. Integration partially with respect to x square. What to further give 1 by d cube 3x square y plus 2 by d one integration. This will be 1 by d means integration partially with respect to x. Partial. X partial. For 1 by d cube 3x square y 3x square y. It is one integration only. One integration. It will be 3x cube by 3. 3 get cancelled here plus 2x cube. 2x cube 3 get cancelled. Now this is 3 times integration. 3 times integration. 1 by d 3x square y plus 2x cube dx partial. 1 by d stands for integration. X cube by 3 x cube y 1 integration 2x power 4 by 4 or x power 4 by 2. Partially again x power 4 by 4 x power 5 by 10 power 5 by 10. This is x power 5 by 20 y x power 5 y by 20 x power 6 by 60 x power 6 by 60. This is your particular integral particular. Or you can get this is the answer. Therefore, general solution is phi1 of y plus x phi2 of y plus phi3 of y plus 2x y plus 2x plus x power y by 20 plus x power 6 by 60. X power 6 by 60. I'll have you try in the same manner here. Solve d square minus 2 dd dash of z equal to x cube y. D square minus 2 dd dash of z equal to x cube y. Idea is very simple. In the particular integral, you have to take highest power of d as a common element. Okay? Highest power of d as a common element. Here you have taken t cube as a common element. Then take the next term into the power minus 1. Then apply binomial series. In the binomial series, you have to see the series goes to infinity. Therefore, you have to stop the series. Therefore, concentrate on highest power. Numerator's power here. Numerator powers. If suppose numerator is for d, then you have to think about x square, x power here. Because suppose x power is 2 means you have to move up to d square. But numerator is for d dash. What you have to think about y power is 1. You can stop with d dash. You can stop with the d dash power 1. Then operate the expression here 3x square y, then 2 by d of t dash of therefore 1 derivative you can find here. Then 1 by d stands for integration. 1 by d stands for integration. That's all. 1 by d cube stands for integration. Integration with respect to x only 3 times. Yeah. The same manner, you try d square minus 2 dd dash of z equal to x cube y. Well, if you try this problem and give your answer.
Sir,
Uh,
phi 1 of y
uh,
plus phi 2 of y plus 2x
uh, y plus 2x
that's
CF.
all, sir. CF. Phi is x power
Okay.
5 by 60
Uh,
into bracket la
60.
y plus uh,
Uh,
bracketல வந்து 3y plus x sir.
3y.
Same answer sir. X power y by 20 plus x
This
power
is
6 by
common.
60. Yes sir.
Okay. 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 அதே ஆன்சர் தான்.
Yes sir.
Okay. 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 Could you
Sir,
please
your
check that
voice is
you are getting
breaking, sir.
the same answer or not? Voice is breaking.
Yes, sir.
From yeah, from initial time onwards it's breaking.
Yes, sir. From
Huh?
starting itself, a little bit.
Break is there.
Yes, sir.
Okay. Maybe some network issue. Okay, we'll rectify. Similarly, we have after three standard functions: exponential, and cosine or sine. Second type. Third type is algebraic polynomial. Algebraic polynomial. Then after that, you have product of functions here. Product functions here. Exponential into other functions here. Exponential into other functions. Either exponential into sine or cosine, or exponential into algebraic polynomial. Algebraic polynomial. We can proceed by the shortcut idea is that you replace d by, when exponential in the product here, you replace d by d plus a and d dash by d dash plus b, the coefficient of x and y here, the coefficient of x and y of exponential, d by d plus a and d dash by d dash plus b, then you can get some other function. And in that case, you take it into the e power ax plus y out of the operation, e power ax plus by to f of x comma y here, f of x comma y. That manner we can write here. Therefore, we can, for a right hand side f of x comma y, we can have a single functions only, either cosine or sine or algebraic polynomial. Or we can proceed by that type of idea here. We can proceed by that type of idea. We can get that either type 2 or type 3. For right hand side single function, you can proceed by either type 2 or type 3 idea here. Type 2 or type 3 idea. Okay, right. Is type next 4. RHS equal to exponential product exponential into cosine or sine or x power m y power n, algebraic polynomial, any of the type here. In that case, particular integral equal to 1 by e power ax plus y, x plus by into the same functions. In that case, you have to replace d by d plus a, d dash by d dash plus b, d dash plus b. Replace d by d dash plus d plus a, coefficient of x of exponential and coefficient of y of exponential b, b dash plus b. Then you can get some other function phi of d comma d dash. In that case, you take exponential out of the operation. Now right hand side is either cosine or sine function or algebraic polynomial. Then proceed by either type 2 or type 3. Proceed by either type 2 or type 3. Either by cosine function idea, cosine sine function idea, or algebraic polynomial idea. Either cosine sine function idea or algebraic polynomial function. That one we can. Okay? Right. Take some problems here. Solve d square plus d dash square of z equal to e power x into cos of x plus 2y. E power x into cos of x plus 2y. Product of exponential and algebraic sine cosine here. Auxiliary equation is m square m minus 1 equal to 0. Pi 1 plus x pi 2 y plus s and pi 2 y plus s. Same roots here. And particular integral 1 by d square 2d dash plus d dash square of e power x cos of x plus 2y. Here a equal to 1. A equal to 1. B 0. B 0. For replace d by d plus 1. D dash by d dash only. D dash by d dash plus 0. That is equal to d dash only. But d by d plus 1. Because a coefficient is 1. So 1 by d plus 1 square by d plus 1 square minus 2 times of d plus 1, but d dash is d dash only. D dash is 0. D dash square. D by d plus 1. D dash is d dash. D dash is d dash. D dash square. In that case, you take e power x out of the operation. D dash square is plus cos of x plus 2. D square plus 2d plus 1 minus 2d d dash multiply minus plus d dash square. Cos of x plus 2. Cos of x plus 2. Or e power x. E power x. Now every combination is there here. Or what about cosine function idea? Replace d square by minus 1 square, d dash by minus 1 into 2, d dash square by minus 2 square. Minus 2. So, d square by minus 1, but 2d no change, plus 1, d dash by minus 2, d dash no change, d dash square by minus 4. Cos of x plus 2y. 1 minus 1 get cancelled here. Minus plus 4 minus 4. That is also get cancelled here. Therefore, we can get 2d minus 2d dash cos of x plus 2y. I'll take two common element here. Common element. For e over x by 2, I will take 1 by x dash 2 common x plus 2y cos of. What about further multiply by conjugate? Multiply by conjugate d square minus dash square. What about remaining thing? We place d square by minus 1 square, d dash square by minus 2 square. D plus d dash minus 1 square minus 1 minus 4 cos of x plus 2y. Cos of x plus 2y. So e power x by 2 is minus plus 4 minus 1 3 3. Therefore, e power x plus 6 minus plus 4 minus 1 3 of d plus d dash of cos of x plus 2. D means dou by dou x. This is dou by dou y. Dou by dou by dou y. For e power x by 6, dou by dou x means sine minus sine of x plus 2y. Dou by dou y means minus sine of x plus 2y into 2 because dou by dou y. Minus 2 sine of x plus 2y minus sine of x plus 2y or minus 3 sine of x plus 2y. For e power x by 6 minus 3 sine of x plus 2y. For minus e power x by 2 sine of, this is your particular integral. This is your particular integral. Okay. Minus e power x by 2 minus e power x by 2 sine of x plus 2y. That will be your answer. Okay. Right. I think all of you understand this idea. When the product is there, exponential into other function product is there. You see the e power ax plus by, what is x coefficient, what is y coefficient. And then x coefficient means plus x by d plus a, x coefficient. Then d dash by d dash plus b, y coefficient. You can get some other function of d comma d dash in the denominator. You take exponential out of the operator and you keep right hand side. Now you have cosine function only. Cosine function means you know the procedure. Replace d square by minus a square and so on here. Then we can get these relations. No, this way. Then we can proceed as usual like a type 2. Then we can get the answer. E power minus x by 2 and so on. Right. Now I will give one problem and one condition also. Put a note here. when e power x plus ax plus by into x power m y power m in the RHS, when we replace d by d plus a and d dash by d dash plus b, d dash by d dash plus b, if we get constant in the denominator, if we get constant in the denominator, we have to take that constant, as a common element, in the denominator. You have to take the constant element, as a common element in the denominator, because x power m, y power m means you will take highest power of d as a common element. But here, when constant appears, you see the previous problem, when you replace d by d plus a, d plus b, you see that a constant appears here. So in that case, you have to take this constant as a common element when you have x power m, y power n here. Because if you take highest power of d as a common element, that constant goes up to infinite level. One goes up to infinite. Therefore, you cannot stop the series. So if you want to stop the series, you have to take constant as a common element. Then only you can easily stop the series. Otherwise, you cannot stop the series. It goes up to infinity. So for that purpose, you have to take constant as a common element here. That will be the idea. We have right hand side x power m, y power n with the exponential here. Based on this idea, you have an exercise problem. If possible, you try and check z, not y, z equal to e power x plus 2y into 2 plus 4x. 2 plus 4x is an algebraic polynomial, a single algebraic polynomial. Don't take it as particular level 1, particular level 2. Treat it as a one single algebraic polynomial. No y, only x power 1 only present. Yes, it is product of exponential into algebraic polynomial like x y power n relation. So I'll have to take down this problem and try in the leisure time. Yeah, right. Okay. Okay, that's all this session.